Thank you, and welcome again to Endava TechFlow. It's great to see so many people here. Thank you for making the time to be here. I'm Owen Woods. I'm Endava's Group CTO, and by now you might have you guessed that I wasn't Macedonian? No, you did guess. Okay. So, as you'll find out when I try and pronounce any of my colleagues' names later on, it'll be extremely amusing, I'm sure. So I'm going to give a talk about blockchain, which was quite nice because we had a little bit of a reference to blockchain beforehand. And then we've got a talk about actually programming blockchain immediately afterwards. So what I'm going to talk about is what a blockchain is and its interesting characteristics. And I'm originally, as in until quite recently, I'm a solutions and software architect. So when I look at a piece of technology, I want to know what I can do with it. It's all very well it being cool and new, but what can I actually use it for in a real system? And that's sort of what I'm interested in, is what is blockchain when you think of it as an architectural element that is a piece of a system? What's it useful for? And then once we understand that, what are people actually using it for? Because although blockchain's mainly known for Bitcoin, there's an awful lot of other things it's being used for. So let's start by asking, what is a blockchain? Well, everyone knows it's part of Bitcoin, don't they? Has anyone here not heard of Bitcoin? And they won't put their hands up anyway. No. So Bitcoin's obviously very high profile. Who's got some Bitcoin? Who's bought some Bitcoin? Nobody? A few? Yeah. Who's actually managed to spend any Bitcoin? No, nobody. Yeah. Because you can only buy really dodgy things with Bitcoin. And it's the key thing about it, what it really is, it's a database that's very distributed. It's copied to many places, which has got good and bad points, but it doesn't have a controlling authority, because nearly every database you can think of, there's somebody or something in control of it. And you know the weird thing about blockchain databases is no one's really in control. Everyone's in control. They're sort of democratic from that perspective. And technically, people describe it as an auditable database with provable lineage. How dull does that sound? Unless you're an accountant, when you're probably very excited by it. But what it really means from our perspective is you can be sure what's in the database, you can be sure it hasn't been tampered with, and you can be sure how it got there. And actually, if you think about that for a minute, that's quite useful, because we quite often want to know that our databases haven't been changed. And what it really means in security terms is you can now collaborate with people you don't trust. Think about business relationships that you have. Do you deal with anyone you don't know? Do you deal with anyone you don't have a contract with? Do you deal with anyone you don't trust? Not very often. You mainly deal with people you trust. And the idea of blockchains is they allow people to collaborate in really specific ways without actually having to trust each other very much. Because the rules of the game are so strong and so well enforced, you just know how everyone's going to behave. And of course, we know that they are used for cryptocurrencies. Cryptocurrencies need a way of people trusting each other, and they need a store that allows people to transfer value around. And blockchains are used a lot for that. What I'm interested in, though, is that it comes with these interesting properties about being very reliable, very distributed, very secure. So it sounds to me like it could be a really interesting part of an internet scale system, maybe an IoT system. So I wonder how that would work. There are some terms that people use that tend to get a bit confused with each other. And the first one obviously is Bitcoin, and you all know what Bitcoin is. It's a cryptocurrency. It was the first cryptocurrency, and it was the thing that started the new wave of them. And it's still the most valuable and widely traded cryptocurrency. And it uses a blockchain because you've got to have some way of keeping score. And that's all Bitcoin uses the blockchain for. It's working out where all the money is. A blockchain's a bit more general than that, and they can be used for things other than cryptocurrencies. And they are really implementations of distributed ledgers. And the interesting bit is actually the distributed ledger. A distributed ledgers are fully replicated, meaning everyone's got a copy, in a peer-to-peer fashion of a distributed database. And it achieves trust, and this is the clever bit, without having anyone in control. So that's it. That's a ledger. And you can only append to ledgers. That's why they're called ledgers, because in accounting, you're not allowed to go back and use an eraser and change something further back in history. You've got to just add more transactions to sort things out. So that's why they're called ledgers and not general databases. But where they become really interesting, I mean, it'd be sort of useful to have an append-only database, but blockchains add this layer called smart contracts. We'll look at those in a minute, but a smart contract is code that lives in the blockchain and is executed by all the nodes in the blockchain in a very predictable way. So it allows you to make the blockchain active as opposed to completely passive. You can think of it a little bit like stored procedures for the blockchain era, only obviously it's way cooler than stored procedures because everybody wants to have a go with it. How does it actually work? Use Bitcoin as an example. So we've got two people who want to transfer Bitcoin to each other, and it's a security example, so they have to be called Alice and Bob. That's just a rule, otherwise the whole world ends if you use any other two names for security examples. And because they're called Alice and Bob, we know they're both good people. That's an in-joke for security people. The ethical hacker, I'm sure, will recognize Alice and Bob from a long, long time ago. So in the middle, there's the Bitcoin network. And there's only 3 of them. In reality, there are thousands and thousands of them, but I couldn't put them on the slide. So I've put 3 of them. And you see the blue blocks? And there's 4 of them? That's the blockchain. Now again, the real blockchain's a bit longer than 4 blocks. But let's pretend it's only got 4 blocks, because that's as much as fits in my brain. And the miners all have a complete copy, and they're all communicating with each other. And Alice actually has got a special kind of wallet, as in the wallet's the thing that allows you to see what Bitcoin you've got, bit of software. It's got a complete copy of the blockchain too, which is actually pretty inconvenient because the blockchain's 32 gigabytes and growing, but obviously Alice has got a large computer, so she wants a copy of the blockchain. Bob, on the other hand, has got a mobile phone. He's got an iPad, actually. And his iPad obviously doesn't want to have a 32 gigabyte chain, so he's just got a piece of software that shows him his Bitcoin holdings. And what's going to happen is that Alice is going to send Bob some money. So Alice creates a transaction that says, send this amount of my Bitcoin to Bob, and they're both identified by a long number, which is their public cryptographic key. Okay? That's the way it works. And Alice sends that to any mining nodes that she knows. And they send it to all the other mining nodes that they know. And so quite quickly, that transaction propagates across the network. And once the people in the middle get enough transactions, which is not very many actually, maybe a few tens, they will decide that they're going to put all these transactions together and create a new block for the blockchain. The really interesting thing about blockchain is they all try and have a go at this together at the same time. But only one of them is going to be a winner. Only one of them is going to get there first. And we'll talk about who gets there first in a second. But one of them wins the race and adds the block to the blockchain, and all the other miners go, and they start again. So they throw away all the transactions they had, they get the transactions that aren't in blocks, and then they start trying to create a block. And then that's actually all that happens. Who has not been involved in that at all? Bob. Poor old Bob. He's sitting there on the side. He has no idea what's going on. Well, actually, he has. But the interesting thing is that the only reason Bob knows he's got more Bitcoin is because his wallet has connected to mining nodes and has just asked them, what's up with Bob? Here's his key. And they go, here's his balance. In fact, they don't even say here's his balance. They say here's his transactions. There are no balances in a blockchain distributed ledger. So the thing that sometimes people get confused about is they think about, I've got my Bitcoin wallet on my computer, so I've got my Bitcoin on my computer. Nothing lives in one place with a blockchain. Everything lives everywhere. So Alice has got all the transactions in the world, including the one that she used to transfer money to Bob. All the miners have got every transaction in the world, including the one that Alice used to send money to Bob, and Bob's got nothing, because he hasn't got a blockchain. He is relying on everybody else following the rules and keeping his Bitcoin safe. And that's fundamentally how Bitcoin works. Which is why you can see the first time somebody explained this to the rest of the world went, really? And it took quite a long time for people in banks to go, oh, maybe, which is roughly where they are today. So what does a blockchain look like? If you're a cryptographer, this is blindingly obvious. If you're not a cryptographer, like me, it's not entirely obvious, so it's worth just quickly going over. A blockchain is, every block has the same sort of format, so it's a bit like a database management system. And the way it works at a fairly simplistic level is that every block has a number of transactions in it. The transactions are unique across the blockchain, they're never stored twice, and blocks can have varying numbers for various rather boring technical reasons we'll gloss over for now. But the important thing is a transaction lives in a block. And the way that we make sure that a block isn't going to be tampered with is that we use a cryptographic hash. So that's a technique for taking all the data and producing an improbably large number, which proves that the data hasn't been changed. The really clever bit about a blockchain, though, is, and this is why it's called a chain, obviously, you're all computer scientists and way ahead of me, is that we have to link the blocks together. And the way that this works is we take the hash of the previous block, and then we stick it in our block. And then we include that block in our block hash. So this gives us two things. It means nobody can change the transactions in our block, but also nobody can change the previous block, because we're linked to it with the block hash. And if anybody were to change this block, this previous block hash here, this wouldn't be valid anymore, and all of the miners would just throw the block out and refuse to process it. So that's conceptually relatively simple cryptography for implementing a really quite a clever idea. Because the interesting thing about Bitcoin is the Satoshi paper, no one knows who Satoshi the author is, in fact it's probably a group of people, he brought together a number of previous ideas. It's the synthesis, the combination is the clever thing. That was the genius. He didn't actually invent any new security or ideas. As so many good ideas, it was sort of obvious once he'd written it down. All the cryptographers in the world went, yeah, I guess so. That's how I'd do it too. Only they didn't. It took him. So how do we know the blockchain's correct? Well, basically, everyone has to agree, which is, and of course, being cryptography and security, we can't use the word agree because everybody would understand us. So we've substituted agree for consensus, because consensus sounds magical and mysterious. And it's quite important for security people to sound magical and mysterious as much of the time as possible. Blockchains actually use different types of ways of getting to a consensus. Bitcoin uses a very, very expensive one called proof of work. And if you want to assert that your block is going to be the one added to the blockchain, you have to solve a very hard mathematical puzzle. And the difficulty of the puzzle goes up all the time. And it's now got to the point where to do that profitably, you have to be in China with $500,000 worth of custom hardware and beside a hydroelectric plant. I think most people would agree we've possibly gone too far with the hardness. But unfortunately, the way Bitcoin works, there's no easy way to reverse it. So proof of work is, and obviously, this is a very clever puzzle because it has to be very, very hard to solve and very, very easy to verify. So of course, it's based on prime numbers, the way all of these puzzles are. So what happens is you solve a hard problem. If you're the first one to solve a hard problem, you tell everyone. Everyone goes, oh, you're clever, and then takes your block and adds it to the blockchain, and they throw their work on the floor and start again. I don't know what I've done there. I'm going to just press buttons until it comes back. It's come back. Yes, that was lucky. I did that at a large international conference and it didn't come back. So I had to stand on the edge of the stage making it up while an AV technician came all the way from the back, tutted, and then switched it back on for me. So the whole point about this is that it's very, very hard to forge the blockchain because you'd have to get more than half of all that capacity for mining to fool everyone that actually your blocks, the fraudulent ones, were correct. Because otherwise, everybody else just carries on mining, carries on checking results, and because they're moving faster than you are, you actually can't go back and change history. So it's a very clever technique. Unfortunately, it requires a massive amount of electricity. There are a couple of other models, though. The big banks are working on something called the R3 consortium. They don't want to use proof of work because they want a high-volume, efficient blockchain. So they're just going to use proof of membership. And that simply says, if you've got a signed certificate by the person who, is, or the entity who is considered to own the blockchain, then you can add blocks. Otherwise, you can't. It's that simple. So it's not really it is sort of a race, but it's not really a competitive race. It's just a question of who happens to do the next block next. But of course, the interesting thing about proof of membership is it centralizes control in some way. Because after all, something or someone is deciding who can be a member. Which if you're a large bank, frankly, that's a pretty good thing because you want to control it that way. If you're a cryptocurrency anarchist, That's considerably less attractive. The other model, which I think Ethereum is looking at the moment, is proof of stake. What that really means is there are certain people in this ecosystem who have invested a lot of time, effort, and money and will use that stake to decide who's allowed to add blocks to the blockchain. And so it's things like, what balances do you hold? How much mining have you done? Those are the two I can think of. There was a third one which I've forgotten. But the important thing is it's about contribution to the ecosystem. There's a lot of cryptocurrencies around, you may have noticed, but I don't know if you'll have noticed quite how many there are and how quickly they're now appearing. Bitcoin came out in 2009, and the paper was written in 2007, and Bitcoin started being a real thing about 2009, and along came Litecoin just after it. Ethereum, which is the platform we'll tell you quite a lot more about tonight, is a platform really for doing distributed applications, not just currencies. And it came along in 2015, largely because its founder realized that there were some fundamental problems with using Bitcoin to build applications. And there've been a lot of others since, which I'm not going to read them all, but you can see there's a lot of activity here. And what's interesting is how quickly it's changing. I know you can't read those numbers, but in August, when I did one version of this presentation, there were 10 cryptocurrencies worth more than $1 billion. That's $1 billion. That's a lot of zeros. Bitcoin was 70 billion. Oh, and then when I looked again in September, a few weeks ago, there's 11 cryptocurrencies worth more than $1 billion. They just can't help themselves. But Bitcoin's only worth 62 billion, which is a heck of a change in value in a couple of months. And this is because cryptocurrencies don't have any regulatory or supporting authority. There's no central bank for Bitcoin. Therefore, they tend to be very volatile currencies. They are if you're an economist by training, I'm sure some of you are, you'll recognize that they're a very pure economic construct because they're not distorted by any policies. They are literally a pure medium of exchange and worth what people believe they are worth at any point in time. The only snag is if you've actually owned Bitcoin, that's quite inconvenient because one day it's going to be worth $100 and the next day it'll be worth 42. Which is quite surprising. And it's certainly one of the things that I think holds back real commercial use of Bitcoin as a medium of exchange. Because if you're a large shipping firm, a couple of percent change is quite significant, never mind 50%. So what's it being used for? Loads of stuff. I'm not going to explain them all. But it's being used for things where, independent of any central authority, people want to prove something is true, such as somebody's identity, or they want to track something over a lifetime. The best known of those is Ledger, which is Leanne Kemp's startup. That's not really a startup anymore, they're 5 years old. They track valuable things, and they're most famous for tracking diamonds. And what they do is they cooperated with De Beers, because as you know, diamonds come from quite volatile parts of the world. And there are some places in the world where it's frankly ethically unacceptable to deal with their diamonds. Whereas, of course, by the time it gets to the shop, it's very hard to know. So what Ledger do is they identify the diamonds very early in the process in cooperation with the miners by recording lots and lots of facts about them. And also, I believe they actually attach some kind of tiny identifier to the diamond. And they put that on a blockchain. And they actually use the Bitcoin blockchain because they weren't big enough to ensure security. So they actually use Bitcoin's blockchain, and then that stays there forever. And then as the diamond changes state and changes hands, they put new entries on the blockchain. And at the end, they'll produce a certificate with the cryptographic hashes of the transactions on the Bitcoin blockchain that if you care, you can go and check it. Right at the other end of things, I suppose, in terms of scale, Maersk and IBM are trying to track containers as they go around the world. So this is where IoT meets blockchain meets commerce. They're not actually putting the coordinates of the containers on the blockchain. That they haven't found that to be useful yet. But there's a tremendous amount of documentation that accompanies goods in containers through many ports and many processes until it gets to a final port for distribution. And these things are rather prone to be forged, lost, destroyed, damaged, because they tend to be paper or PDFs. And PDFs are quite easy to forge as well. So what they're using is a blockchain with a set of trusted participants so that people who need to read the documents or change the documents use the blockchain as a verifiable lineage for that document. So you can actually prove where the document has been, who changed it, and what it contained at any point in time. So it's much, much harder to forge. And then there are various things going on in capital markets. If you're working in the banking domain, you can't have not seen blockchain. Every single bank, as far as I can tell, apart from one I visited the other day, who seemed slightly concerned they didn't have a blockchain prototype, they've all got a blockchain prototype, and none of them have anything in production. That is currently the state of the industry, despite all the money being spent. I'm actually not convinced very many of them want to take it to production at this stage. That's my personal theory, because I think if they really wanted to, they would. And there's two particular firms, UBS and Goldman Sachs, where it's kind of interesting. They've both are very serious about blockchain. They've both put a lot of money into it, and they've issued almost no press releases. Whereas most of these banks have put very little money into it, but issued a lot of press releases. I think there's an inverse ratio between numbers of press releases and likelihood of something actually coming to production. So watch this space for those two. The other thing that's very interesting if you work in banking is that the regulators, that's the logos on the right, the regulators are very interested in blockchain. Regulators are not generally, with all due respect to them, the most imaginative or fast-moving organizations. I think the very fact that they're taking it very seriously does suggest that maybe we should too. And I'm not going to browse a blockchain. So what is a blockchain if we were going to build one into a system? So it's a distributed replicated database. That sounds super, doesn't it? Generally speaking, we like distribution and replication. It's distributed via a peer-to-peer model. That might be good or might be a bit annoying. That sort of depends on the situation. It uses consensus, which is a clever name for meaning everyone agrees. And it's append-only and immutable, meaning we can't change it, or rather, it's very difficult to change it once it's been written. It's also highly fault tolerant. At any point in time, some percentage of the Bitcoin miners in the world are working, and some percentage aren't. And you can have actually quite large failures in the Bitcoin network, and no one notices. Possibly the rate of new blocks slows down a little bit, but nobody really notices. So it's very fault tolerant, and but it's very eventually consistent. Who is aware of eventual consistency? Who here uses MongoDB, for example? Sometimes consistent. Then blockchain is eventually consistent, but not the way Cassandra or Mongo are. What they mean is, we'll be consistent just as soon as we can, hang on a moment or two. What blockchain, when it says it's eventually consistent, it means I probably will have your transaction on the chain sometime quite soon-ish. That's really the guarantee they give you. Which, as a software architect, makes my blood run cold, because, of course, my transaction might just get held up forever. You can just get unlucky, and you can certainly get unlucky in terms of time. I have put transactions on the production Ethereum chain and had them on the confirmed, because there's a convention you wait for 5 blocks to be added on top of your transaction. I have had them confirmed with 5 blocks in, like, moments, like in 30 or 40 seconds, mind you. For a database, that's a long time. But for blockchain, that's pretty quick. I've also put them on, and I've just gone away and left it, because it's been hours before I got 5 blocks mined on top. So, it's very eventual in terms of consistency. Strong consistency, but you need to wait quite a while for it. And when you add in smart contracts, they are code of some sort that gets written to the blockchain. Now, for all the developers in the room, what did we say about the blockchain, about data on the blockchain? It can never be changed. Just pause for a moment. Once you've written your code to the blockchain, you can't change it. Have you ever written a piece of code before that you never needed to change later? If so, you are a better developer than I've ever been. This is one of the things about smart contracts. If you look on the Ethereum production blockchain, you will find pieces of code which I'm ashamed to say belong to me, which aren't useful. Because they've got bugs in them, and I've just abandoned them. And actually, Ethereum blockchain's full of them, because it's got quite a clever smart contract language, so it's quite easy to make mistakes. So you've got to bear this in mind with smart contracts. The fact that they're on the blockchain is cool. The fact you can never change the code once you've written it once is, to begin with, a bit surprising, but that is the way it works. The contract languages as well, if you read the popular press, they make it sound like smart contracts are some standard thing that everyone should just start writing tomorrow. In reality, every single blockchain's got a different smart contract language. Bitcoin's got a very, very primitive one that's based on Forth. Anyone remember Forth? used for controlling radio telescopes. Yeah, and it's got a stack. It's not got registers or variables. It's one of those. So it's very, very primitive, deliberately, because they wanted to be able to verify it at runtime very cheaply. At the other extreme, Ethereum have invented a language which is Turing complete, strongly typed, and quite complicated, called Solidity. And we'll see that a bit later. And then IBM Hyper Ledger actually uses a stripped-down version of Go, which was something of a surprise when I found out, but it genuinely does. So they vary a lot. And so that means the programming and execution model vary by platform. It's the same sort of problem you get with public cloud. If you've built an application on Bluemix, good luck moving that to Amazon. If you built something on Hyperledger, don't even think about trying to move it to Ethereum. It just doesn't move. They're completely different models. So this is what a smart contract looks like, which I realize, having walked to the back of the room earlier, you can't see. So I'm just going to show, you'll have to believe me, because I'm bound to be saying the truth, because I'm speaking in public. It looks a bit like normal code. It looks a bit like a cross between JavaScript meets JavaScript meets Pascal, something like that. I know. For those of you at the back, you're thinking, my God, what would that look like? But it's not as bad as it sounds. It's strongly typed, so it's not JavaScript, but it's a bit JavaScripty, because they were sort of inspired by its syntax. But it's got a contract instead of a class, and it's got methods, and it's got state, and it's got clever things called events. Events are how you record the progress of a smart contract on the blockchain. So nothing particularly weird there. So we'll get to some detail. Well, I won't, but we will get to some details later about that. But just take my word for it. So what's it like to use a distributed ledger? It's immutable once written. That's probably a good thing, unless you've made a mistake. See earlier comment to developers. It's secure in that it's high integrity. It's very good for non-repudiation. It's very hard to deny you did something to a blockchain. And it's highly available. Very fault tolerant. Doesn't have a single control point. Again, that's probably good. Helps with resiliency and trust. And it allows you to stick logic into it. So it's a bit like a traditional database. It's also, however, very dynamic and very evolving. Not the blockchain data, but the entire ecosystem around all the blockchains. Every 3 weeks, if you go back to the development documentation, you'll find something annoying has changed in an annoying way. And that's just the state we're in at the moment, is that everything changes all of the time. And as soon as you leave it alone for a couple of months, you'll be bewildered when you go back to it, because they seem to have made some really strong decisions 3 months ago, and now they seem to have changed them all. So you just have to get used to that. The problem is, as I said, it's consistent, but on its terms. You have to be quite patient. It's generally very computationally expensive. Most blockchains, Bitcoin's an extreme case, most blockchains are pretty inefficient. They copy all the data everywhere. Every smart contract runs on every node. That's a pretty inefficient model. One little thing about blockchain is people often describe it as a database, and it's got a surprising characteristic for a database. It's got two, actually. It's quite hard to get the data back out, because most databases have a query language. Blockchain doesn't. Blockchain allows you to ask precisely one thing. Could I get the thing, please, with this very long number? That's literally all a blockchain allows you to do. These websites that allow you to do searches, what they've done is they've got an entire copy of the blockchain, and they've indexed it locally with a rich indexing system. The actual blockchain doesn't allow you to do that. There's a great lack of privacy. The trade-off of everybody trusting everybody is that everybody can see everything. That's quite surprising when people first come to this. A lot of bankers, I think, don't understand that. And at the moment, it's not terribly scalable. There's a lot of work going into fixing this, but right now, there's no way you could move the MasterCard transaction volume onto a blockchain. You just simply couldn't do it. In fact, it's tens of transactions a second is the current kind of volume. And as I say, it's sort of lacking maturity. The other surprising thing about a blockchain as a database is it doesn't store data very well either. So if there's two critical things a database does, store data and retrieve data, unfortunately blockchain is great, except that it doesn't store data very well and it's not great at retrieving it. Apart from that, it's a great database. It's got a huge trade-off, in other words. It's sort of deliberate that it doesn't store data well, because you've got to copy this stuff everywhere, and you've got to keep running cryptographic checks on it. So the Ethereum people have deliberately made it very expensive to put data in their blockchain, but you can put as much as you want in if you've got the money. Bitcoin only allows you to store small amounts of data, and I think it's 140 bytes, if I can remember correctly, per transaction. So again, it's very restricted. The good news is that there are two systems in the world, IPFS, the Interplanetary File System, which is not really interplanetary, you might have guessed that, and Swarm, and they are both cryptographic cryptographic immutable append-only stores, but for big blobs of data. So whereas the blockchain optimizes itself for small transactions, these guys have optimized themselves for big blobs of data, but with fundamentally the same kind of idea. And obviously, you can link the two together by using the ID of the thing in the big blob store in your transactions on a blockchain. So that's just worth knowing about, because that's often not mentioned in the sort of blockchain 101 overviews. And so what you normally do is you build a normal system. The stuff above the dotted line is just a normal web app. Say it's Node, or if you're really, really kind of trendy, or it's Spring Boot in Java, if you're like the rest of us and have to get some work done. And it's got a conventional UI and database. Then the middle tier is probably making requests off to a blockchain of some sort. And if you need to store a lot of data, you're actually going to store that in one of the immutable storage systems. So that's the kind of standard reference architecture of a distributed application on blockchain. Ooh, that sounded painful or expensive, one or the other. So the key concepts we've gone over is, what is a distributed ledger? Just remind me. I'm going to have to tell you, aren't I? Have you been listening? Distributed ledger is this idea of a database that stores transactions, but all it allows you to do is add transactions to the end. And the way they enforce that is having a peer-to-peer distributed network where everyone's got a copy of the whole database, and people use consensus, that's distributed agreement, to make sure that everyone's got the same view of the data. And a blockchain is a particular way you can implement that using cryptography. There are, incidentally, distributed ledgers. In fact, R3's Corda is strictly a distributed ledger and not a blockchain, because it doesn't use the blockchain cryptography primitives to keep it secure. And then smart contracts are blocks of code on the blockchain that you can execute to change it. The blockchain's a kind of distributed database, apart from the slight embarrassment about read and write and never being sure when it updates itself. But it is a distributed database. But it's unique because it's append-only. It's very auditable, it's very fault tolerant, and it's very secure. That was by design. It's also slow and high latency. That was by accident, but it's just the trade-off that they make. And most of them can host smart contracts. Things you can do with them include value transfers. That's maybe transferring securities between people, transferring diamonds, transferring Bitcoin. You can put records on the blockchain. Because you can be very sure that things won't change, you could put records of people's property ownership on a blockchain, for example, and be absolutely sure that they're there. You could use it for identity. You could store passports on the blockchain, for example. That's been mooted in a couple of Balkan states. So this may be coming to you sometime soon. You can store things, as we were saying, like documents, what Maersk are doing, store those on the blockchain. Verifiable storage. You can use it as a notary. That is proving that something was true at some point in time, and again, stamp it on a blockchain. And finally, you can use it for currencies, which actually is what nearly everybody who's actually using a blockchain for real is really doing today. If you want to find out more, there's a lot of resources on the web, which I'm not going to read to you, but there's a lot on the web. But those are places that I'd suggest you start, because they're good places to, they're good and reliable places to find out more. Thank you.
Okay, really nice presentation. I have two questions. The first question is, does anyone in this hall knows about XAPO, XAPO, a Bitcoin blockchain payment processor? And the second question is, does anyone knows about the www.bankera.com? It's an initiative for forming of the first digital bank for blockchain transactions, and it's run by the member of the European Parliament called Antanas Guoga, and he is also a professional Texas Hold'em poker player.
So he's a very obvious man to get involved in Bitcoin then. I have heard of the first name you mentioned, which I've now immediately forgotten. the payment processor. I have heard of them. I haven't heard of the second. I don't know if anybody else has. Zabo, thank you. Yes, I've come across Zabo. Anybody else? Hands up? Seems not. So.
Hi, I will play a villain now. I want to
I expect nothing less.
I want to flood the network with false transaction, and that means that everyone will work on the net. All the miners will do a job for nothing. How do we?
I missed part of that in the middle. I'm really sorry. Could you repeat it?
All the miners will need to validate my transactions that are.
Oh, you're going to
false, that
send
are
poison transactions to the network?
Yeah, I'm flooding it because there is no mechanism. Let's say there is no blacklist for miners, or.
So the question is, how would you avoid me poisoning a blockchain network with very, very small or invalid transactions? The answer is you can do that, providing you can afford to. All blockchain networks have the same basic principle, which is either you're a member, in which case if you do that, we'll come around and slap you, or we don't know who you are, but you have to pay to get a transaction on. So they try and manipulate the price such that it would be prohibitively expensive to flood the network with bad transactions. I think actually some of that reasoning is a bit optimistic when you consider that some nation states might want to do exactly that, but that's currently the reasoning that I've heard.
Another one, not so interesting question, but if the ledger is a problem to keep it as a storage, like let's say 32 gigabytes, can some of my friends keep it for me and I have network that can give me information from the ledger to transfer to the global network? So I can separate the storage, separate the logic on separate places. So I can sell storage to Bitcoin miners, for example.
Yeah, so the question is, can you separate the mining from the storage part? I think technically there's no good reason why you can't, but actually in practice today, I'm not aware of any blockchain implementations that allow you to do that, because the mining node is always monolithic. But it's an interesting question, actually. I think the Ethereum one, which is the one I know more about, there's no reason you couldn't have separate peers that cooperated. If you had some way of splitting the transaction mining fees, yeah, I think you could do that. But, I mean, it hasn't been done. So.